Hello students, today we'll discuss IB Physics HL paper 1, May 2019, time zone 2. No calculator in this paper. My name is Nariman Mealim. I'm located in Baku, and here you can see my mobile and email. So sources to prepare for exam: main huge textbook Oxford 2014, short textbook Tim Kirk Oxford 2014, and from examiners IB Physics Guide 2016. But you must have physics data booklet first assessment 2016 copy. This copy will be available for you at the exam, so be accustomed, learn the formulas. Let's start. So this is cover page. First question: a student measures the radius r of a circular plate to determines its area. The absolute uncertainty in R is delta R. What is the fractional uncertainty in the area of the plate? I give reference to the booklet, formula booklet, subtopic 1-2. So if you have power, then you should exponent. So fractional uncertainty is exponent by fractional uncertainty of base. So here we have pi is constant, so r squared. Using this formula, we have a fractional uncertainty for A equals 2 times fractional uncertainty in R. So we choose answer A. Question 2. A proton has momentum 10 minus 20 newtons second, and the uncertainty in the position of the proton is 10 minus 10 meter. What is the minimum fractional uncertainty in the momentum of this proton? Subtopic 12.1, uncertainty formula. So delta x times delta p more than h over 4 pi. Divide both sides by delta x. So rewrite for delta p and then divide both sides by p. Then substitute values and we get answer, which is C, 5 times 10 minus 5. Question 3. A boy throws a ball horizontally at speed of 15 meters per second from the top of a cliff that is 80 meters above the surface of the sea. Here resistance is negligible. What is the distance from the bottom of the cliff to the point where the ball lands in the sea? So vertical motion is, we have constant acceleration. 5 equations available from section 2.1. So we have S80, U0, initial velocity, G981, positive, time, question mark. So no V, so we choose formula without V, and we find the time. So time will be square root of 1630, which is 4.038. And horizontally it moves at constant speed 50 meters per, so velocity by time 50 meters per second by our time found, we get 60.6, which is B. Question 4. A book is at rest on the table. What is a pair of action-reaction forces for this situation according to Newton's third law of motion? In Newton's third law of motion, we talk about two objects, A and B, and the forces with which they act on each other are equal. So we find the combination where we have two objects, A and B, so Earth and book on Earth. In the rest, we have not such combination, so we are swapping object A to object B. So answer C. Question 5. An object has a weight of 610 times 10 to the second Newton. What is the change in gravitational potential energy of the object when it moves through 8 meters vertically? So subtopic 2.3, change of potential energy equals change of height times mg. Mg is weight, so weight we know, we substitute, and we should keep Here only two significant figures, because change of height is two significant figures, and answer should be with two significant figures. Answer with two significant figures is B. So we choose B, and answer is the same as we got. Question 6. The graph shows the variation of momentum with time for an object. What net force acts on the object for the first 2 seconds and the second 2 seconds of the motion? So subtopic 2.4, force equals change in momentum divided by time. Here it will be gradient, and first gradient is 10 Newton, and then it is 0. So 10, 0. So we choose answer A. Table tennis ball of mass 3 grams is fired with a speed 10 meters per second from a stationary toy gun of mass so much. The gun and ball are an insulated system. What are the recoil speed of the toy gun and the momentum of the system immediately after the gun is fired? Subtopic 2.4, momentum equals mass time velocity. Law of conservation of momentum. Total momentum before equals 0, hence total momentum after is 0. Momentum of tennis ball is so much. Momentum of gun should be opposite. So rewriting formula for momentum for velocity, knowing the momentum of gun, mass of gun, we have velocity of gun. So we choose answer A, 0, 0, 5 and 0. Question 8. This is a bit tricky question. A block of weight W slides down a ramp at a constant velocity. Constant velocity means that resultant force equals 0. A friction force F acts between the bottom of the block and the surface of the ramp. A normal reaction acts between the ramp and the block. What is the free body diagram for the forces that act on the block? So let's talk about A. So if we add force F to force N, we will not balance force W. The same for B. But in C and D, it looks as if the forces are balanced. But we should not forget that it is object sliding on the ramp, and normal reaction equals normal component of the weight. So this is true only for D. This is why out of C and D we choose D. So here the forces are balanced. So if you add all forces, you will get closed triangle. Resultant force equals 0 plus normal force is balanced by normal component of weight. Question 9. A substance changes from solid phase to the gas phase without becoming a liquid and without change in temperature. What is true about the internal energy of the substance and the total intermolecular potential energy of the substance when this phase change occurs? This question is not about ideal gas, so potential energy counts. Intermolecular potential energy is increasing when molecules are farther. This happens in solid gas change. Internal energy is sum of potential energy and sum of kinetic energy. As temperature doesn't change, kinetic part doesn't change, but potential part increases. Internal energy increases. So we choose C. Internal energy increases and in total intermolecular potential energy of the substance increases. Question 10. Satellite X is in orbit around Earth. An identical satellite Y is at higher orbit. What is the correct for total energy and kinetic energy of satellite Y compared with satellite X? So let's look for a higher. Subtopic 10.2. Potential energy is minus gm/r. Kinetic energy is half mv squared. and putting here orbital radius, we get GM, actually 2 times less than potential energy. We add, we get minus GMM to R. At higher orbit, R is greater, kinetic energy is smaller, total energy less negative, so larger. So we choose B. Question 11. The escape speed from a planet of radius r is v escape. Satellite orbits the planet at a distance r from the surface of the planet. What is the orbital speed of the satellite? Subtopic 10.2. Escape velocity, orbital velocity, but here is trick. Escape velocity from the surface, but orbital velocity as height r, so from the center is 2r. Substituting these values, finding ratio of orbital to escape, so it appears to be 1 over 2, and it is v orbital equals 1 over 2 v escape, so it is A. Some questions are tricky, so I mean 2 times distance. A liquid of mass m, a specific heat capacity C cools. The rate of change of temperature of the liquid is K. What is the rate at which thermal energy is transferred from the liquid? So subtopic 3.1, formula for energy and mc delta T, divide by delta T. So the rate at which, so delta T over delta T is K. So we get kmc, so kmc is D, 12. Question 13. The equation PF over T equal constant is applied to real gas when ρ is the pressure, P, where P is the pressure of the V is a volume and T is temperature. What is correct about this equation? It is empirical. All 3 gas laws are empirical, so combined equation is also empirical, so it is A. Cylinder X has volume V and contains 3 moles of ideal. Cylinder Y has volume V over 2 and contains 2 moles of the same gas. The gases in X and Y are at the temperature T. The containers are joined by a valve which is open so that the temperature doesn't change. What is the change in pressure in X? So this is a bit difficult question. So subtopic 3.2, PV equals nRT, N is number of moles. So for gas X, before we have this relation, so Px equals 3RT over V. For Py, we have this relation. After combining these 2 gases, so we have mixture of gases, the volume is now V plus V over 2, pressure is new pressure, and number of moles is 5 moles. So we will rewrite this and we get expression for new pressure. Then we find change of pressure in X. So final pressure minus initial pressure. So we get RTV over 3, so which is A. Question 15. The graph shows the variation of the displacement of wave with distance along the wave. Wave speed is so much. Wave displacement. What is the period of the wave? So from the wave displacement, we can find wavelengths. We know speed, so we can find frequency and then find period. So subtopic for 1, period equals 1 over frequency. Subtopic for 2, traveling wave, C equals F over lambda. So F is C over lambda. Lambda from the graph. F from C over lambda, and T 1 over F. So we get to 2 significant figures. It is C. An object at the end of a spring oscillates vertically with simple harmonic motion. The graph shows the variation with time of displacement x of the object. What is the velocity of the object? This is a bit tricky question because we need formula with, not the formula that is given is subtopic 9.1, simple harmonic motion, but we need for more general formula with adding with phase. So all Also, omega equals 2 pi over period, and period here, tricky, period here is 2t, not t. Period is 2t. Two squares is 2t, not t. So formula for x, because x starts from negative value, I think that here we can, if we use sign, and we imagine a unit circle, to get negative sign, we should have phase minus pi over 2. So we substitute everything into the formula, into this formula. So 2 pi over period, phase minus pi over 2, then we start with negative sign. And we find velocity as first derivative of displacement. After using formula of cosine of sum, we get this expression A. So I look to this transformation. So we use cosine of. So first of all, when we find derivative, it is chain. We use chain rule, so sine turns into cosine, and we also should multiply by derivative of the argument. Okay, next, question 17. A massive spring is displaced from its equilibrium position. Which graph represents variation of acceleration with displacement of the mass after it is released? So 9.1, simple harmonic motion, acceleration equals minus omega squared x or minus kx, where k is positive. So it is straight line with negative gradient, so it is d. Unpolarized light is incident on two polarizers. Axes of polarization of both polarizers are initially parallel. The second polarizer is then rotated through 360 degrees as shown. Which graph shows the variation of intensity with angle for the light reaching the second polarizer? Second polarizer. Leaving the second polarizer. Sorry, leaving the second polarizer. So formula is subtopic for 3, I squared cosine squared. So let's see what happens to cosine squared. At angle 0 it is 1, then 0, then 1, then 0, then 1. So we have 1, 1, 1. At the beginning we have 1. And in the end we have 1. So it is answer B. So cosine squared is for this. Question 19. A student blows across the top of the cylinder that contains water. First harmonic standing wave sound is produced in the air of the cylinder. More water is then added. The student blows, so this is the first harmonic standing wave is produced at different frequency. What is the nature of displacement in the air at the water surface and change in frequency when the water is added? So here we have always node, and node at the surface with more water. So here we have node, antinode, lambda over 4. With more water, node, antinode decreases, lambda decreases, and frequency increases. So answer is D. Question 20. A certain harmonic standing wave of wavelength 0.8 is set up on a fixed string fixed at the both ends. 2 points on the waves are separated by distance 0.60 meters. What is the possible phase difference between the 2 points of the wave? So because it is third harmonic, so we have node, 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 and distance between two nodes is lambda over 4, lambda over 2, and so it is 0.40 meters, and because 0.6 is more than 0.40, the points are in different subsets. In each subset we have the same phase. So we have pi radian, so antiphase, C. Question 21. Train approaches a station, sounds a horn at constant frequency and constant distance. An observer waiting at the station detects the frequency and intensity. What are the changes, if any, of observing frequency and intensity as the train slows down? This is tricky question. This is why I put here 3 stars. So moving source, if it is approaching, then frequency is increasing. But here the train slows down, so US decreases. It means that frequency decreases, not increases. From subtopic 4.3, intensity depends on distance, and the closer the object is, the greater is intensity. It doesn't depend on anything but distance. It doesn't depend on frequency. So we choose answer D, intensity increases and frequency decreases. 2 stars are used with telescope using a green filter. The images of the stars are just resolved. What is the change, if any, to the angle of separation of the images of the stars and the resolution of the images when the green filter is replaced by a violet? Filter only continuously change intensity, so no change and remains resolved. Question 23. The particle with charge NE is accelerated through potential difference V. What is the magnitude of the work done on the particle? Subtopic 5.1. Potential difference equals work by charge, so work equals charge by V, so NEV. So easy question. E. Some questions are easy. Question 24. In an experiment to determine resistivity of materials, students measure the resistivity of several wires made from pure materials. The wires have the same length but different diameters. Which quantity should the student plot on the x-axis and on the y-axis to obtain a straight line? Subtopic 5.2, resistivity array over L. It means that resistance equals 4 rho L pi d squared. R and D are inversely proportional, hence 1 over R is directly proportional to d squared. 1 over R, d squared. So we choose answer C. Question 25. 3 resistors are connected as shown. The voltmeter is ideal and the cell has 12 volts with negligible internal resistance. What is the reading on voltmeter? Voltmeter measures voltage across a load, across the 6 ohm and 6 ohm. So let's first find, so using subtopic 5.3, first we find total resistance. It is 6 ohm, 6 ohm give us 3 ohm in parallel. 3 ohm and 1 ohm in series give us 4 ohm. Total resistance is 4, so we divide total EMF by total resistance, we get 3 ohm. And then 3 ohm over 3 amperes through 3 ohm resistance give us 9 volts, so it is D. Question 26. The input to a diode bridge rectification circuit is sinusoidal dial with a time period of 20 milliseconds. Which graph shows the variation with time of the output between X and Y? So this bridge let the current to go to positive current to go through 10 seconds, and then let the opposite current to go. So first it goes that way, and then it goes that way. So 20 seconds, so positive and negative becomes positive and positive, so it is choice A. Question 27. 3 identical capacitors connected in series. Total capacitance of the arrangement is 1/9 millifarad. The 3 capacitors are then connected parallel. What are the capacitance of parallel in a range? Subtopic 11.3. Parallel, we just add. Series, we add inverses. For 3 identical, in parallel we have this formula. In series we have C over so in series we have 3 over 3, so as a result we get C equals 1 over 3. So we substitute this value for parallel circuit, we get 1. So answer is B. 28. A transformer with 600 turns in the primary coil is used to change alternative root mean square potential from 240 to 12. When connected of the secondary coil lamp labeled 120 12 volts, the current in the primary coil is 0.60 when the lamp is lit. What are the number of secondary turns and efficiency of the transformer? So subtopic 11.2, from this subtopic we can find from voltages and 600 turns we have secondary 30 turns. Power output is on the lamp is 120. Power input will be average will be root mean square by root mean square. So current by voltage 144. Subtopic 2.3 efficiency useful power by total power we get 83. So answer D. Circular coil of wire moves through a region of uniform magnetic field directed out of page. What is the direction of the induced conventional current in the coil for the marked positions? This is a difficult question, and so when coil 1 is moving, magnetic flux is increasing. It means that the current inside the coil should decrease magnetic field, so create magnetic field into the paper. This magnetic field is created if current is clockwise. So this you can check by right hand grip rule or by drawing here letter S. Opposite process happen at coil's position 2. Magnetic flux decreases, so induced current should, according to Lenz's law, induced current should increase this flux by creating the same magnetic field, so anti-clockwise or counterclockwise. So answer is C. Position 1 clockwise, position. So this is difficult question. Question 30. Electron is fixed position in a uniform electric field. What is the position for which electrical potential energy of electron is greatest? So I have drawn picture here. So force on electron is to the right, and if you put it on D, it will accelerate and gain potential kinetic energy at the expense of potential energy. It means that at B it has greater energy than at B. At A, at C, equipotential points, so the same energy. So answer is D. Question 31. A proton of velocity v enters a region of electric and magnetic field. The proton is not deflected. An electron and alpha particles enter the same region with velocity which is correct about the passes of electron and alpha particles. Subtopic 5.1. Electrical field strength equal force over charge. So force electrical equal QE. Subtopic 5.4. Magnetic force is QVB. Sine 90 is not 1. Proton not deflected, it means that electrical force equals magnetic, and it means that E equals VB. Here we notice the charge is cancelled, so electron and alpha particle also will be not deflected. So choice D. Question 32. A particle of mass 0.02 kg moves in a horizontal circle with diameter 1 meter with an angular velocity of 3p radian. What is the magnetic and direction of the force responsible for this motion? Subtopic 6.1. Force is m omega squared r. R is radius, so not 1 meter, it is half meter. And we get so many newtons. Circular motion force is always towards the center, so we choose answer D. Question 33. A radionuclide with atomic number Z undergoes a process of beta decay, beta plus. What is the atomic number to the nuclide produced, and what is another particle emitted during the decay? In beta plus decay, proton turns into neutron. Atomic number is the number of protons, so changes to Z minus 1. As beta plus is antiparticle with lepton number one, it should be accompanied by neutrino with lepton number plus 1. So we choose answer A, neutrino Z1 minus 1. 34. The P plus meson contains an up quark. What is the quark structure of the P minus meson? Subtopic 7.3. So P plus consists of R quark and D antiquark to get charge plus 1. To get charge minus 1, U anti-quark and D quark works. So we choose C. 3 conservation laws in nuclear reactions are the following. The reaction is proposed. Which conservation laws are violated in the proposed reaction? So we write reaction. Charge 0, minus 1, plus 1. Antineutrino no charge, not violated. Baryon number. Baryon, a quark and antiquark, so not baryon. 0 baryon, and electron is not baryon. Lepton number. 0, 0, so antiparticle minus 1, antiparticle minus 1, minus 2 is not equal to 0, so 2 and 3 are violated. Baryon number and lepton number. 36. Neutron collides head-on with a stationary atom in the moderator of nuclear power stations. The kinetic energy of neutrons changes as a result. There is also change in probability that this neutron can cause nuclear fission. What are these changes? During collision, part of momentum and kinetic energy is transferred to nucleus. Probability of nuclear fission increases with more number of neutrons. So we choose answer B. Decrease in kinetic energy of neutron and change of probability is increased. 37. The orbital radius of Earth around Sun is 1.5 times that of Venus. What is the intensity of solar radiation? Of the orbital radius of Venus. Solar constant is given in the data booklet, and it is intensity falling on Earth. Subtopic 4.3 tell us that I equals k over x squared, where k is constant. So let's find ratio of intensity of Venus and Earth. We substitute k is cancelled, so we get ratio of Distances squared, 1.5 squared. It means then we rewrite for intensity for Venus, so it will be Earth intensity by 1.5 squared. Earth intensity is solar constant, so we get 3 kilowatt over meter squared. So answer D. 38. Protons of a certain frequency incident of metal surface cause the emission of electrons from the surface. The intensity of the light is constant and the frequency of protons is increased. What is the effect, if any, on the number of emitted electrons and the energy of emitted electrons? So, subtopic 7.1, energy of photon equals E equals HF. So as frequency increases, energy increases. Intensity is number of photons per second multiplied by energy of photon. As intensity is constant, energy of photons increases, rate of photons decreases. Hence, number of emitted electrons also decreases. So we choose answer B. Number of emitted decreases, energy of emitted electrons increases. So as energy of photon increases, energy of emitted electrons will be difference between energy of photon minus work function, so increases. So answer B. 39. Three possible features of an atomic model are orbital radius, quantized energy, quantized angular momentum. Which of these are features of the Bohr model for hydrogen? Bohr stated that orbital radius has some definite value, so it is quantized. Angular momentum is quantized. Energy is quantized, so it is answer D. Question 40. Proton of discrete energy are emitted during gamma decay. This is evidence for. Gamma decay is a result of processes nuclear, so we use B, nuclear energy levels. Paper is over. Thank you for your attention.